Now sometimes we can't graph the line in standard form or it's not in standard form, so we may have to use just tables. Now we use tables in standard form also, but sometimes we have to kind of come up with another way to do these because they're not in standard form. So again, we're going to use our tables a little bit more creatively. And here's an example. Y equals 2/3 x minus 2. So you see it's not in standard form. We could still try to work on at least one of the zeros. Because if x is 0, I can find out what y is. That's pretty easy. I could just, when x is 0, 2/3 of 0 is 0, so y equals -2. So I can use x being 0. And I come up with y equals -2. But when y is 0, without putting this in standard form, I'm not going to be able to see what it is. So what we can do is we can find another value of x and put this in here and find out what y is. And since I've got 2/3 of x, I want to pick a number that's going to be divisible by 3 because that's going to make my fraction work a lot easier. So let's say x is 3, that's good enough. Or even 6, that would work. So let's try x being 6. I want to keep on my graph here, so I don't want to go farther than 6. So if x is 6, let's put 6 in here, and I can kind of work it out. Y equals 2/3 times 6 minus 2. Now, 2/3 of 6, 3 goes into 6 twice. And then 2 times 2 is 4, so that would be 4 minus 2, which is just 2. So you see we kind of worked it out as an evaluation problem. Okay? In other words, when x is 6, 2/3 of 6 is 4. 3 goes into 6 twice. Or you could say 2 times 6 is 12. 12 divided by 3 is 4. And then we've got minus 2, so 4 minus 2 is 2. So now we've got a good point. So just pick a number. If you've got a fraction, try to pick a number that's going to be divisible by the denominator of that fraction, then you won't have any more fractions to deal with. And then we could put our points down and graph this. So we've got the point 0, -2. So when x is 0, y is -2, so I do have my y-intercept. And when x is 6, y is 2, so I don't really see the x-intercept. It probably will be a fraction. So those are our 2 points, 0, -2, 6, 2. We get out our trusty straight edge, connect our points with a line, and we're in business. Straight lines, arrows at the end. Oh, well, the intercept actually was 3. That's pretty good. Okay. All right, and then over here, now we've got these lines here where we have just one variable. So these might be seem a little tricky. Always remember this. If you have x equals or y equals. All right, if you have x equals or y equals, you will have either a horizontal or a vertical line. Either a horizontal or vertical line, like on your T-chart, all right? One or the other, for sure. X equals or y equals, you will have either a horizontal, like the horizon, or vertical line. Which is which? Well, if you get those confused, then it's real easy to use the table anyway. So we could write x and y. And what does this tell us? This tells us that x is -3. Does it matter what y is? No. All it says is x is always -3. So I can pick a couple of values for x. And remember, we only need 2 points to determine a line, a unique line. So when x is, I just pick a couple times when x is -3, because x is, that's all they tell you. X is always -3. So it doesn't matter what y is. So I can pick anything for y. Any number for y. So I'll just pick 0 and 4. And that should work. 5, 6, 7, whatever. All I know is no matter what y is, x is always -3. So if I put those points down, -3, 0, so -3, 0, and -3, 4. 1, 2, 3, 4 up. And then I can connect those. I will have points, and any point on this line, the x will always be -3. You can try any point on that line, and the x will always be -3. So you have a vertical line. All right? Now on this vertical line, we talk about the slope, and here we know if we have an oblique line, this is what we call an oblique line, or kind of like a diagonal, but it's really what we call oblique, and it has a positive slope because as I move from left to right, I'm going uphill. We always go from left to right, just like our number 9 goes from negative to positive. We always go from left to right, and we're going uphill. That is what we call a positive slope. A previous problem we did over here, this has a negative slope because as I move from left to right, I'm going downhill. This line has a positive slope because as I'm moving from left to right, I'm going uphill. This has a negative slope. As I'm moving from left to right, I'm going downhill. So you can kind of tell what's going on with the slope. Now, when we have a vertical line, that's so steep that we actually say the slope is infinite, which is really undefined. So in this case, we would say that the slope m, remember m is what we use for slope, m is undefined. So if you have a vertical line, the slope is undefined. We don't know what it is because it's so steep. Because it's rise over run, it's all rise, there's no run. Okay? So again, something like this or something like this will either be a horizontal and vertical line, and if you're not too sure, just use the table of values. All right? Let's try this one over here, y equals 2. So again, I'll use my table of values. I know this will be a horizontal vertical line, so x and y, and I know that y is always 2. It doesn't matter what x is, so I'll put a couple of 2's there. And I can do the same thing over here. I can use 0 and 4 again. It doesn't matter what you use. You can use anything. I just happen to use 0 and 4. And that will work because all I know is that y is always 2. So I'll put my point in when x is 0, y is 2. And when x is 4, y is 2. And we have a horizontal line. And any point on that line, the y will be 2. That whole line is 2 units above the x-axis. So any point on that line, the y will be 2. It's a horizontal line. And what's the slope? Well, there is no rise, it's all run, so the slope is 0. So we would say m is equal to 0 for the horizontal line. Our slope is 0. Okay? And the last one, well, this looks like it's in standard form, so it looks like it would be easy to graph, so I could put x and y, and I could put my zeros here, but when x is 0, if I divide 0 by negative 3, I get 0, so y is 0. Well, that's okay. 0, 0 is a point, but when y is 0, I get x is 0, so I only have 1 point. So this one goes through the origin. But I need another point for the line, so I have to kind of figure that out. And I can put numbers in, but it's easier to solve for one variable in terms of the other, so I'll do that over here on the side. And what I'll do is I'll add 3y to both sides, so I can separate my variables. Add 3y to both sides. And I've got 2x equals 3y. Then I'll divide both sides by 3. And I have y equals 2/3 x. So y equals 2/3 x. So what I can do is I can find a value of x now, and then I can figure out what y is. And I want to pick again a value of x that is divisible by 3. So let's try 6 again. That worked before. Hate to do the same thing, but so when x is 6, what's 2/3 of 6? That's what y is. See, if whatever I put in for x, I can find the corresponding value for y. So if I put 6 in, what's 2/3 of 6? Well, 2 times 6 is 12, and 3 goes into 12 4 times. So then we get 4. So those are our 2 points, so now we can graph it. 1 point is 0, 0, and that's the problem because the x and the y-intercepts are the same. So we don't get 2 intercepts, we just have 1, it's the same. And then we can go out, x is 6 and y is 4, so 1, 2, 3, 4, 5, 6, up 1, 2, 3, 4, and there's our other point. So it does go through the origin. So we have to use an alternate method because we get both intercepts the same. So here we go. And again, put the arrows at both ends, and there's your line. Okay, so again, you can go back, pause these, and check these out, and that gives you a pretty good idea of how to graph lines.